But we didn't stop. If I don't do it, our young children, they'll never know the fish.
Grade 11s. We continue then now with trigonometry. We are still busy with trigonometry, and today we're looking at the area of a triangle. Now, we know now of a right angle triangle, it is half base height. We can work with that one, half base height. But then we're going to look in the area of any triangle. ABC. Now, before we start with that, you first need to understand the following. We label the side opposite the angle with a small letter. So that is side A, this is side B, and this is side C. And the formula that we're going to use now for area in any triangle is half BC sine A. Now, if you look carefully there, you will see it's always two sides and the included angle that we're going to use to calculate these areas. In the textbook, you can look there now on page 463, and we're looking at try now 23. Now, this is very easy because this is just in right angle triangles. If you look there on the exercise, it's just a right angle triangle. We work with half base height. Just remember that your base and your height must be perpendicular. So if we take the first one there, number 1A, it will then be a half of 24 times 8. And my answer there is 96 square centimeters. It's area that we are calculating. Right, number B. Now, what's important here is which two sides are you going to choose? They must be perpendicular, so it is a half of 18 times 9 that we will use there. And I got 81 square centimeters. Number C, it must be the perpendicular ones. Now, look at that one. The base will be 16, and the perpendicular height is 19, half base height. They must be perpendicular. Here I got 152 square centimeters, and then number D. So there you just work in that one triangle, so it's a half of 22 times 26, half base height. We just need to calculate the shaded area there, and it is then 286 square centimeters. Or in a case like this, you can get the area of the rectangle and divide it by 2. Okay, so now we're going to look in any triangle. This is then now any triangle. So let's just make sure that we understand the following. If this is triangle ABC, then this is A, this is B, and this is C. And the formula that you're working with now, area, is half BC sine A. Half BC sine A. That will give us the area. So we're busy now with try now 24. That's the first one that we should look at there. In the triangle LMN, now I'm going to draw it just to get the idea LMN, what are we talking about here? And they say MN is 6.8, NL is 3.8, and N is 76 degrees. There you can see it's the two sides and the included angle. So we're using this formula, half height, half BC sine A. This is what we're working with here now. So it will be a half of 6.8 times 3.8 and then sine 76 degrees. You can just press your calculator, 0.5 times 6.8 times 3.8 sine 76. And I have 12.5 square centimeters on that one. Once we know the formula, it is very easy to do this. The next one is number 2. Find the area of an equilateral triangle. Again, I'm drawing the picture, 10 centimeters. What do we know about the angles of an equilateral triangle? We know that they are all 60 degrees. So I can still use my formula, half BC sine A. Half BC sine A. So it's then a half of 10 times 10 sine 60 degrees. Sine 60 degrees. You just press the calculator there. I got 43.3 square centimeters. Right. The next one is now try now 25. Page 465. Okay. So these are now the ones. And you will see they're talking about cast also there in the example. And so we can also have that more than one angle then there. Right, let's look at the first one. In PQR, every time I'm going to draw the picture to find out which side is which one. Otherwise, you're going to struggle here. So PQ is 5, QR is 8. And now they gave us the area is 19 square centimeters, and we have to calculate Q. So it will still be a half of BC sine A. So now it will be a half of 5 times 8 sine A. This is what we want to calculate. And we have the area now to be 19 square centimeters. You have that area, so you equate it to that one there. So it will then be sine A. We do opposite operations. Here you divide by 2, so there you will times with 2. Here we will divide with 5 times 8. And eventually we will say second function sine that value then there. And I got 71.8 degrees. 71.8 degrees. It might be, this is now if it's an acute angle like this. But now remember, the picture can also look like this because we don't know the size of Q. So it might have been an obtuse angle as well. So all that we do then is we say 180 minus that 71, and then I got 108.2 degrees. So it might have been that as well. There's more than one possibility. Right, number 2, triangle ABC. ABC. And BC is 4, AB is 6, the area is 11, and we have to find B. Can you see? We have to find that included angle. So the formula is half BC sine A. So it is then a half of 6 times 4 sine A. This is what you want to calculate. And this we equate it to 11. We equate it to 11. So sine A is then equal to 11 times 2, opposite operations here, divide by 6 times 4. And you will say second function sine, second function sine, and A, look there that I write A now. It doesn't stay sine A. That's mathematically not correct. It's A now. And A is 66.4 degrees. Again, it could have been an obtuse angle. It might have been that obtuse angle there. So 180 minus that, and the other possibility is 113.6 degrees that we have there. Right, question 3. So we've got the sketch there. All that we do here is they've combined it now with algebra. Great. Now, what they say is the area is 18 square centimeters. So again, half BC sine A, and in this case, it is 18 square centimeters. So a half, just going to work with algebra, x plus 1, sine 30 degrees is equal to 18. Okay, we need to find x now. So if you press your calculator, then you will see sine 30 is a half. So I actually I would want to get rid of this half, and I will then get rid of this half. So we're going to say that this is 18 times 2 times 2, because I multiply with a reciprocal here. Sine 30 is a half, I multiply with the reciprocal. So now this part here is then x squared plus x. So eventually I have x squared plus x, and now I can calculate that value there. 18 times 2 times 2 is 72. So plus 72 is equal to 0. And then how did we solve these equations, these trinomials or quadratic equations? Can you remember what times what gives you the first term? X times x. Which factors of 72 will give me a 1? Sorry, this one will be a minus here because I bring it over. So if I subtract it, it must give me 1, and that would be 8 and 9. Signs differ. The biggest combination is positive. This is the biggest one, and this one is negative. So x is equal to 8, or x is equal to negative 9. And now you have to make a choice, and which one will we choose? This one, because the length of a triangle cannot be a negative value. Right, question 4. So we've got a parallelogram there. And this angle is 74 degrees. So they say the area is 100 square meters. Find the value of x. Now I'm going to work in the triangle, not in the rectangle. So half BC sine A. So now I'm not going to equate it to 100 because to 50 because I divide it by 2. So it is then a half of 2x times 3x sine 74. So multiply by 2 there, so it will be 50 times 2, divide by sine 74, and this will be 6x squared is equal to. So now you can just calculate that value. We will divide it by 6, you will square root it, and the answer is 4.16. 4.16. Right, and the last part is then now try now 26. So try now 26. A hexagon, a regular hexagon. Right, so the first one is then a hexagon, number A there. So a hexagon, so we know that it will be 6 times the area of one triangle there. and that is then a half. BC is 6 times 6. That's the length of the side, the radius then there, and then sine 60 degrees, because that is, if you have a hexagon, these angles there is 360 degrees, so one will be sine 60 degrees there. And this is then 93.5 square centimeters. At number B, the two areas are equal, so we're going to equate it to that one, and it is then a half of 2x squared times sine 110, and then I got that x. So this will then be 2x squared is equal to 93.5 times 2 divided by sine 110. And then eventually you'll have to divide by 2 and root it. So 93.2 divided by sine 110, divide by 2. So I got 49.59. And if we root it in there, it will be 7.04. 7.04 will then be there.
God said. It's interesting to see if we have a look at John 1. In the beginning was the Word, and the Word was with God, and the Word was God. In other words, what I see drives me to go out what I say. And I believe this is the goal of our Bible school, to teach me to see. And I dare to say what you see must change your heart. Because you cannot move out if you don't have a changed heart. By the word of God, everything is created. God wants you to speak the word so that things can be created. Say to your neighbor, created.
Win free airtime with #LearnOn1. Share your comments on the lessons. WhatsApp your feedback, name and town to 081 200 6659. #LearnOn1. Invite learning in.
Today we're looking then at the sine rule. This is now when we work in any triangle, the sine rule. And as we said in the previous lesson, the first thing that you need to understand is that in a triangle, if this is triangle ABC, then this is side A, this is side B, and this is side C. That's the first very important fact that we need to know, and what we're going to use here. Now, we can use the sine rule to find angles or the sides. And you will use this one if you have two opposite ones. So the angle and the side, and another angle and a side. Or it might be C as well. So the rule says A over sine A is equal to B over sine B. But it doesn't matter now, it might be C as well. Two sides and two opposite angles. The one that you want to calculate is the one that we're going to put in the left-hand top. So if it is a side, we're going to use this one. But if it is an angle, then we will say sine A over A is equal to sine B over B. So the one that we want to find is in the left-hand top. Now in your textbook, this is now C, what we are talking about here. Now it is triangle LMN, and now they say that angle L is 60 degrees, angle M is 34 degrees, so I've got two angles there. LN is 3.8 centimeters, and this is what we need to calculate MN. So if you look here, you can see I've got a side and an angle, or opposite side and an angle, and the same thing here, the opposite side and the angle. And that's when we're going to use that sine rule. So I'm going to put the one that I want to calculate in the left-hand top. So this is then x over sine 60 degrees, which is equal to 3.8 over sine 34 degrees. So the opposite side and angle, opposite there. Now to calculate it now, this is with algebra that we will do it. I want to find x, so this is going to be 3.8. To get rid of this one here, to have x alone, I will multiply with sine 60. So what I do on the one side, I do on the other side, and then we divide by sine 34 degrees. And that's then just a calculation that we're going to do on our calculators. So 3.8 times sine 60 degrees is equal to divide by sine 34, and I got 5.885. It's also important that we will look at the rounding. So I got here 5.885. Sides are going to be rounded to 3 significant figures. So there is 3 significant figures. Will the 5 influence the 8? Yes, and it becomes then 5.89. 5.89. Right, number B. Try now 27. Again, we're drawing the triangle PQR. Now, if I look there, I see that P is actually 120 degrees, so perhaps we can rather draw it like this. That one is 120 degrees, R, and this is then Q. Angle Q is 20 degrees, and PQ 57 centimeters, that one then 57 centimeters, and I have to find RQ. That is what I want to calculate, RQ. Opposite sides, opposite angles. No, because I actually need this angle. Can you see? I've got that side, but I need that angle there. It must be opposite. But we can easily calculate it in here, and we know then that R is going to be 40 degrees. So now I can use my sine rule. Remember that sine rule says A over sine A is equal to B over sine B. So we want to calculate X or QR, and we put that one in the left-hand top. So this is now QR over sine 120 degrees is equal to 57 over sine 40 degrees. And again, to get QR now, I will multiply here, and I will also multiply on the right-hand side, sine 120 degrees, divide by sine 40 degrees. Divide by sine 40 degrees. So on my calculator, 57 times sine 120 is equal to divide by sine 40. And the answer is then, I got 76.795. Again, rounding it then to 3 significant figures. There's 3 significant figures. Will the 9 influence the 7? Yes. And it is rounded then to 76.8. 76.8. Okay. Right. The next one is number C. In triangle ABC, so I draw the picture so that I can see which one is which one. A, now they say A, the small letter A is 8. Angle A is 70 degrees. And angle B is 32 degrees. And we have to find B, which is now this one. The small letter opposite the angle. So that will then be over sine B, sine 32 degrees, is equal to 8 over sine 70 degrees. So I will multiply 8 times sine 32, divide by sine 70, and the answer is, I got 4.51 centimeters. The next one is number D. Again, triangle PQR. We again have an obtuse angle there, Q, which is 105. So PQR. P is 27. And R is 15. R is the small letter there, so that one is 15. And we have to calculate Q. This one here. Opposite sides, opposite angles. Now here we can see we need angle R because this one is opposite that side and we don't have that one. But we can easily get that. So it is 180 minus 105 minus 27, which is equal to 48 degrees. Don't just take any angle. They must be opposite the side. So I want to calculate Q. Q is opposite sine 105 degrees is equal to, and now I'm taking this one, so it is 15 over sine 48 degrees. Here we do multiplication. 15 times sine 105 divide by sine 48. Divide by sine 48, and the length of Q is then 19.5 centimeters. So these ones were all about finding the side. Okay. Now we're going to look at the next one where we are finding the angle now. So this is now try now 28, and we are busy on page 4.